Chapter 11, number 52. A puck on a horizontal frictionless surface is attached to a string that passes through a hole in the surface as shown in the figure. As the puck rotates about the hole, the string is pulled downward, bringing the puck closer to the hole. During this process, do the puck's linear speed, and angular momentum each increase, decrease, or stay the same? I'm going to actually answer this in reverse order because what we have here is a force that when we pull the string downward this way, pulls the puck towards the center. But that means that if we're looking from above, so here's the puck, and it's trying to sweep out sort of this circle, let's say, and we are exerting a force like this towards the center of the circle, which is the center of the table, then the line of action of that force is radial, which means that the r perpendicular is 0, and therefore the torque, which is r perpendicular times F, is also 0. But if the torque is 0, then the change in angular momentum is also 0, because the change in angular momentum is the torque. So L is conserved. So the first thing we have is part C. L remains the same. But then for part B, we know that in general, L is I omega. Decreasing R, which is what we're doing here, decreases I, because I is some number times the mass times the radius squared. Since the mass doesn't change and the radius gets smaller, so does I. But decreasing I increases omega, since I omega is a constant. So we find that in part B, omega increases. And that gives us part A, because we know that for an object traveling in a circle at a rate omega, we know that V equals R omega. Now things are a little complicated, because we know that R is going down while omega is going up. And the question is which of those is going to win. But we know that basically, if we go back to our earlier equation up here, where we have L equals mr squared omega, then this says that omega is L over mr squared. And so V is R times L over mr squared, or something like L over mr. And so as R gets smaller, V gets larger. In other words, the impact on omega overwhelms the decrease in R, and so V also gets larger.